So question one here is more of an exam style question. The first one is normally how they start off any question on Hooke's law, which is just state Hooke's law. And it really is that force on a spring is directly, we can sometimes omit that word, proportional to the extension. A lot of people just write length in there, and it's not, it has to be the extension. And then people tend to leave the last bit out, which is provided the limit of proportionality is not exceeded. Okay. B then gives you a set of data for seatbelts, and it shows you the load, gives you the length, and gives you the extension. And asks, what is the natural unstretched length of the seatbelt? We look at where the load is 0, and it tells us the length at the start is 120.5 centimeters. It then says, explain up to what load in kilonewtons does this seat obey Hooke's law? Well, if we look at the data, and Hooke's law is all about the load and the extension. We can ignore the length of the seatbelt in this case. But to get from there to there is plus 1.5. From here to here, plus 1.5. From here to here, plus 1.5. From here to here, plus 1.5. But from there to there is plus 2.5. From there to there is plus 3.5. So you can see there's a nice constant change up to that point, and then after that the extension begins to increase. So that's really be part 1. Part 2 then is up to 2.0 kilonewtons, because the increase in extension is the same for each 0.5 kilonewtons added. Of additional force up to 2.0 kilonewtons. When the load is removed, the seatbelt always gets shorter. In one case, a load of 5 kilonewtons is applied and then removed, and in another case, a load of 1 newtons is applied and then removed. In what way, if any, does the length of the seatbelt after the load is removed compare in these two cases? Well, after the load of 1 kilonewton is removed, the seatbelt will return to its original length. The reason I know that is it's a Hooke's law up to there. And if it's a Hooke's law, the limit of proportionality will not be exceeded, and then definitely the elastic limit will not be exceeded. After the 5 kilonewton force is removed, it is unlikely, we don't have enough data actually, but we'll say it's unlikely that it will return to its original length. As the elastic limit is likely to have been exceeded. Okay, we know from our data that the limit of proportionality has been exceeded at 2 newtons. The elastic limit is usually just after the limit of proportionality. So if a limit of proportionality is 2 kilonewtons, it's likely 5 kilonewtons will involve the elastic limit having been surpassed. When a car is involved in a major accident, it is wise to replace the seatbelts. Explain why. With the large forces involved, it is likely the elastic limit has been exceeded. Therefore, seatbelt will not return to its original length and will have a permanent deformation on it and will not function properly.